Hello again, and welcome to Crazy Math Productions. Today we're looking at the Chapter 5 review, going back over writing linear equations in various forms. We're going to start off with a word problem. An editor gets an 890 raise each year. In her fourth year, she is making 99,400 a year. Write a linear equation in point-slope form, which models her income in terms of how many years she has worked at the company. Well, first of all, point-slope form. That's very important. We're going to be looking at the point-slope form, which is y minus y1 equals m onto x minus x1. Kind of important to point out that y1, m, and x1, you're going to be plugging things into those three. We're not going to plug anything into the y and the x for point-slope form. You just leave those alone. Now, she gets an $890 raise each year. That's your slope. That's change over time. That's how her salary is adapting each year. Now, in her fourth year, she makes 99,400. That's an ordered pair. So we have this order pair for 99,400, and we have the slope. So we're just going to simply plug it in. Y minus y1 equals m onto x minus x1. And it says write a linear equation in point-slope form, and that will be it. Next, find an equation for the line with undefined slope. It's very important, passing through this point. We've got to think, an undefined slope, that's going to be, you'd think, this has a slope of 0. So that does not have an undefined slope. This has an undefined slope. Well, if you look at your coordinate plane, this is the x-axis, this is the y-axis. You can kind of notice that they are sort of inverses of each other. A line that looks like this is an x equals line, which corresponds to the x-axis. It's like you're changing back and forth. This is an x equals type of line because it's the opposite of the x-axis. The y-axis goes up and down, which is the opposite of a horizontal line, which would be a y equals line. So it's the opposite of the axis you would think of it as coming from. So this is a vertical line. It has an undefined slope, mostly because you're going to be dividing by 0. You cannot divide by 0. That gives it undefined. So x equals something. This is going to be my type of line. Well, look at this point and tell me, what does x equal? It equals 4. So x equals 4. That's my equation. Number 3, a real estate sales agent receives a salary of $250 per week, also receive a commission of 2% of sales. Well, you're thinking in terms of, there's 3 different things you could have. You could have a starting point, you could have a rate of change, or you could have a sort of when this happens, that happens. So if it's a starting point, that's your y-intercept. If you have a rate of change, that's going to be your slope. And if you have when this happens, that happens, that's a point. And in any of these word problems, you can have some kind of a combination of any of those 3. So in this case, $250 per week. So that's really where he starts making money. He's at the basic level going to make $250. So I'm going to go ahead and write down that's the y-intercept, $250. Now, how does he get money over time? Well, he gets 2% of whatever he's able to sell. So as he's able to sell more, he gets 2% of that. That's a change over time. That's my slope. So write a linear model. If you followed Crazy Math Productions, we've talked about our clues. Well, we have both major clues right here. Y equals mx plus b. All right, number 4, write an equation with a line shown on the graph. Again, if you've followed Crazy Math Productions, we talk about our clues. First one is the slope. The second one is the y-intercept. If we look through, the y-intercept is positive 2. That's where it hits the y-axis. So that gives me one of my clues. As far as the other clue, we're going to make a rectangle. And let's start from this point. So we're going to rise 2 blocks. So that's a positive 2. Then we're going to run 1, 2, 3, 4, and that's a negative 4 since we're going to the left towards the negative numbers on the x-axis. So my slope is going to be positive 2, so my rise, over the run, which is negative 4. We can simplify this down to negative 1/2. And so I have both major clues. Y equals mx plus b, so y equals negative 1/2 x plus 2. All right, write the equation of the vertical line that passes through the origin. Let's think about it. The origin is the point 0, 0. So here's the origin right there. We're talking about a vertical line, so let's go ahead and sketch a vertical line. Through that point. Now, as I talked about earlier, the line, whether it's x equals or y equals, is sort of the opposite of the axis. Same letter, but corresponds the same way. So x-axis is an x equals line. It's a vertical line. So we're talking about an x equals something type of line. X equals are always vertical, y equals are always horizontal. So now, x equals what exactly? Well, the origin is the point 0, 0. But what does x equal? X equals 0. So that's my equation. An airplane leaves its home airport, travels away at a constant speed. 2.5 hours later, it is 400 miles away. Write an equation giving the distance d at any time, t. So I'm going to go ahead and write an equation giving distance d at any time, t. Usually, the time is first, so t and then the distance. This is also a way of saying write an equation giving the distance d in terms of the hours t. So usually they give the dependent variable first, which is the second one in our traditional order pair, and they'll give the independent one second, which is our traditional x in the order pair. So I'm just writing this down just so I can remember that these are the variables that I would normally think of as x and y. Now they're t and d. Now, an airplane leaves its home airport, travels away at a constant speed. 2.5 hours later, it is 400 miles away. So the time is 2.5 hours. The distance is 400 miles. Now, it doesn't give us any other information, but really it has. It says it leaves its home airport. Well, if it leaves its home airport, it's been 0 hours since it left. It's also been 0 miles because it's at home. So we're going to use this point here in our equation. The y-intercept, we've got 2 clues. First one, slope. Second one, y-intercept. Well, the y-intercept is 0. Whenever x is 0, the y value there, that is your intercept. So y-intercept is 0. The slope, well, I'm actually going to have to calculate this. You can use the traditional y2 minus y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. I just like using the non-traditional puppy formula. If you follow Crazy Math Productions, you've seen that as well. So we're going to do y sub 1 minus y sub 2 over x sub 1 minus x sub 2. Get the 400s on the top, 2.5 on the bottom, 0 on the top, 0 on the bottom. So subtract, we get m equals 400 divided by 2.5. For this, I'm going to change it to the old school division symbol, and then 2 times 2 is 4 plus 1 is 5, so this is 5 halves. I'm going to change, flip, rationalize the 400, and 5 goes into 400, 5 goes into 40 8 times with the 0 behind. 80 times 2 is going to be 160. So my slope is going to be 160. I'm guessing miles an hour here. All right, so I've got my slope, the y-intercept, right equation. Well, my equation would normally be y equals 160x plus 0. But in this case, instead of y, write a d. And instead of the x, we're going to write a t. It's optional whether you put the plus 0 or not. It's sort of up to you. Okay, what type of relationship, positive, negative, or none, shown by the scatter plot? We've got to think. The general trend is upward here. So something like that. General trend is upward. Now you got to think, from left to right, is it going up, down, or is it not really showing any kind of pattern? Well, left to right, it's going up. So that's a positive relationship. Positive relationship. All right, number 8. A grocery store knows that if it sells its canned hams for $6 each, it can sell $7.50 per month. If it sells the same hams for $10, it'll sell $700 per month. Assume the relationship between price and sales is linear. Write the equation you could use to predict sales for other prices. Well, here's the thing. You've got to think in each situation, this is a traditional word problem. We're finding an equation. There's 3 things I could really throw at you. First one is a change in time. Rate, change in time, change over time, excuse me. So in this case, you could think of this 750 per month as a slope, but really in context you can see it's paired with another number. Now, neither one of these, none of these seem to be some kind of a starting point. That would be more of a y-intercept. It's, as far as the slope goes, you could have thought of this, but if you look at it in context, it looks more like there's 2 pairs of something. Well, if there's 2 pairs, that's definitely pointing to when this happens, then that happens. Those are some ordered pairs. So we're going to go 6, 750. It's my first ordered pair. And 10, 700 as my second ordered pair. At this point, we're just going to write our equation. I'm going to use the little puppy non-traditional formula. 750 on top, 6 on the bottom, 700 on top, 10 on the bottom. Subtract. So m equals all of this. We end up with 50 divided by negative 4. We can reduce that down to negative 25 halves. I'm just going to leave it that way. Now, if you look at our close, first of all, m equals negative 25 halves. B, well, we're not sure what B is. So we're going to pick one of these two. Looks like this one's probably easier to work with, so I'll use that one. We've got the zeros at the end. Just looks a little easier to work. So we're going to pick one of these, and we're going to plug into y equals mx plus b. Y is 700 equals m, which is negative 25 halves, x, which is 10, plus b. So now we're going to rationalize the 10. 700 equals. Now, the shortcut here is to say 10 divided by 2, which is 5. 5 times 25 will be 125. Or you could say 25 times 10 is 250. Divided by 2 would be 125. It will work either way. And we're going to add the opposite to both sides. And we have b equals 825. So we have our two close. We have negative 25 halves and 825. And that's all that we need for the linear equation. Y equals negative 25 halves x plus 825. And there we have it. All right, number 9. We're going to make a scatter plot of the data, draw a line of best fit, and find an equation of the line. Let's look the smallest to the largest. We have a range of about 8. Let's see on the x-axis exactly how many we have. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like going by 1 is probably appropriate. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now let's look at the y. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. And looks like our range is from 1 and 75 hundredths to 7. So it looks like going by 1 would be appropriate. Let's move on. We're going to graph these individual pairs. So for example, this is going to be one order pair, 1, 1 and 75 hundredths. How exactly do we graph that decimal? We're going to look between the two nearest whole numbers, between 1 and 2. It is closer to the 2, however, so we will graph 1 to the right, 1 and almost 2, not quite. And so now we graph our next one, 2, 2 and 8 tenths. So we say 1, 2, almost 3, not quite. Because 2 and 8 tenths is very close to 3, but beneath it, underneath it. 3, 2 and 65 hundredths. 2 and 65 hundredths is just a little bigger than 2 and a half. 1, 2 and a half, just a little more. 4, 4. That one's straightforward enough. 5. This is almost 4 and a half as far as just graphing it. 1, 2, 3, 4, 4 and a half, roughly. 6, 5 and 8 tenths. 6, 1, 2, 3, 4, 5, and 8 tenths, almost to 6, but not quite. 7, this is just a little more than 5 and a half. 7, 1, 2, 3, 4, 5, 5 and a half, a little more. And 8, 7. All right, now we're going to draw a line of fit for our scatter plot. Now, I don't have my line tool with me, but we're going to do the best we can. Now, I'm just eyeballing it. You can see I'm looking this direction here. The first thing I want to do is sort of visualize where do I think that the y-intercept could go. Well, I think that my y-intercept would be right around here in this area. So I'm going to make life easy on myself. I'm going to pick an easy y-intercept to deal with. If this is my line, I think this is going to be the easiest y-intercept to deal with. So I'm going to create my own point. I'm allowed to do that as long as the point is within the range of these other points, as long as it's not somewhere up here and doesn't fit with the rest of the points, or with a trend of the data. And so my y-intercept, I can immediately tell already, is going to be +1 because I've made it that way. Now, I'm going to go ahead and try to sketch my line. And again, really should use a straight edge for this. I don't have my line tool with me. And so we've made the scatter plot. We're going to draw the line of best fit. Now we need to find the equation. Well, we've already started thinking about our close. We've got the y-intercept. We also have the slope. Now, I've made one good point here. What I'm going to try to do now is to try to find, see these little dots here. These are the intersections of where the grid comes together. So I'm going to try to find another good spot where my line is going through, not necessarily one of the existing data points like here, here, or here. It doesn't have to be those. But I do need to find something that's exactly over this line. And I can fudge it just a little bit. I can move it just a tiny bit. Looks like this one is a good fit. You can see the line is crossing over the grid at exactly 3, 3. Now, again, we have a data point that is not 3, 3. It's just above it. But our line, our trend line, would go through at exactly 3, 3. And that's what we're looking for. So now, to find this slope, we're going to need to draw a rectangle. And now rise and run. So we're going to rise 1, 2, +2. We're going to run 1, 2, 3. It's +3. So rise over run, that's 2 divided by 3. And I'm close enough here. I've got both major close. Y equals m x plus b. So have I made the scatter plot? Yes. Have I drawn my line of best fit? Yes. Have I written my equation? Yes. I've done all three. And it always is helpful to make sure that you've answered the directions. All right. Write the equation of the line in slope-intercept form that passes through the points 7, -1 and 2, 9. Well, I'm going to copy these points again and do the non-traditional slope formula. You got to think, our close, first we want the slope, second of all we want the y-intercept. So we're going to use the slope formula. I'm actually going to use the non-traditional formula, -1 over 7, 9 over 2. Subtract these. M equals, it's going to be -10, keep change, divided by 5, which is -2. So my slope is -2. I need to find my y-intercept. I could do this one of two ways. I could do it the way that we had started the chapter, or I could put it in point slope and then quickly convert. I'm going to opt for the earlier method. I'm going to pick 2, 9. Just think that point is going to be nice to work with. You could easily choose the 7, -1 if you like. But we're going to say y, which is 9, equals m, which is -2, x, which is 2, plus b. So again, we're using y equals mx plus b. That's the slope-intercept form. And we're simply plugging in this point, x, y, and the slope, -2, into this. So we're going to solve for the one part that is missing. 9 equals -4 plus b. I'm going to add 4 to both sides, and b equals 13. So this is my second clue. So my equation is going to be y equals negative 2x plus 13. All right, write this equation in standard form. Well, one of the most important parts of standard form is that we have a, b, and c as integral numbers, as integers. So we're going to need to get rid of the denominators here, the 3 and the 6. We need to try to figure out exactly what can go into both 3 and 6. Well, if I just list these, 3, 6, 9, 6, 12, 18, looks like the least common denominator, the least common multiple is going to be 6. So I'm going to multiply everything by a positive 6. 6y equals 6 divided by 3 is 2, times negative 2 is negative 4. Don't forget the x. Minus 6 divided by 6 is 1, times 7 is 7. So I'm going to bring this up here. I'm going to add 4x to both sides. So we have 4x plus 6y equals negative 7. And that is in standard form. ax plus by equals c. A is positive. A, b, and c have no common factors. And a, b, and c are integers. Okay, number 12 here. Write the equation of the line in slope-intercept form that passes through the points negative 3, 5, and 2, negative 5. Well, this is very similar to number 10 here. First, we're going to find the slope. I'm going to rewrite this down here. Use my slope formula. Negative 5 on top, 2 on the bottom, 5 on top, negative 3 on the bottom, subtract, keep, change, and we end up with m equals negative 10 divided by 5. It gives me a slope of negative 2. Again, we're going to look at our close. First of all, slope. Second of all, y-intercept. Now the slope is negative 2. So now all we need to do is pick one of these points. It doesn't matter which one. I guess I'll pick the second point here. And we're going to plug it into y equals mx plus b form. Y is 5. M is negative 2. X is negative 3 plus b. So we're going to multiply negative 2 times negative 3. It's positive 6. Subtract 6 from both sides. B equals negative 1. So I have both major close. I'm going to plug them in. Y equals negative 2x. I could say plus a negative 1 or just simply minus 1. All right. A revenue of $1,500 is obtained from the sale of item A at $50 each, item B at $25 each. Write an equation that shows a relationship between the number of items sold. Well, here's the thing. This does not fit any of the other models. This is a standard form type of equation. For standard form, remember we have ax plus by equals c. Well, in this case, the sales of item A, you're going to multiply by $50. You're going to add that to the sale of item B, which cost $25. All that revenue combined is going to be $1,500. And at this point, you have a choice. You can put it into formal standard form, which means you need to divide each one of these by 25. But really, it just said write an equation. So it did not specify that it be in standard form. So this would actually be acceptable. Now, let's go ahead, just for the practice of putting in standard form, go ahead and get the common terms. We're going to divide both by 25. That's 2a plus 1b, or just b, equals 25 into 150 is going to be 6, and then, of course, the 0 at the end here. That would be the official standard form. But again, 50a plus 25b equals 1500. The way that the directions have been written, that would be acceptable. All right, number 14. Point-slope form. Remember, point-slope form, y minus y1 equals m onto x minus x1. We plug things in, y1, m, and x1. So let's go ahead and do that. We have x, y. We're going to plug all this in. Y minus y1, which is negative 3/2, equals m, which is negative 2/3, onto x minus x1, which is 2/3. I'm going to keep change here because I don't like this double negative, but otherwise this is correct. That's my slope-intercept, my point-slope form. The reason they call it point slope is because you can see the point and the slope. So that's my point-slope form. All right, number 15. 1980, the average price of a home in Brainerd County was $95,000. By 1987, the price was $123,000. Write a linear model for the price of a home P in terms of the year T. Now remember, they usually give you what the traditional Y, what you would normally think of as the Y variable first. Then they give you what is traditionally the X variable. So we have Y, then X. So my order pairs will look like, instead of X, Y, they'll look like T, P. All right, so T equals 0 is 1980. Now you look through, these don't look like a rate of change. These don't look like a starting point. It looks like some order pairs. Looks like they've given us 2 order pairs. So 1980, that is the year 0. So 1980, which is 0, and then 95,000. That's my first order pair. My second order pair, 1987. Well, that's 7 years past 1980. The price is 123,000. Now we need to write a linear model. So I'm going to look for my 2 clues. Slope and the y-intercept. Well, the slope, I'm going to put 95,000 on the top. See if I can find some room here. And 0 on the bottom. 123,000 on top. And 7 on the bottom. We're going to subtract these, divide them. 95,000 minus 123,000. It's going to be 28, negative 28,000, divided by negative 7. And if you divide this out, that's going to be 4,000. So m equals 4,000. Now my y-intercept, if you're looking carefully, t equals 0 corresponds to 1980. 1980 is the very first year. So if you think about it, this is really a starting point. That would be my y-intercept. Also, you can see where x is 0, the y value is my y-intercept. This means that this point is actually on the y-axis, which makes it my y-intercept. So 95,000. So normally I would write it y equals m, which is 4,000, x plus b, which is 95,000. But again, we don't want y and x, we want P and T. So we're going to put P equals 4,000 X. Oh, gosh. We don't want X. We want T instead. So P equals 4,000 T plus 95,000. Okay, number 16. Clear up a little bit of room here. Write the equation of the horizontal line that passes through the point 7, negative 3. Let's think about it on the coordinate plane here. This line corresponds to this axis, like opposites. So this is actually an x equals type of line. This line, horizontal line, corresponds to the vertical axis, which is the y-axis. So this is a y equals type of line. Well, we want the horizontal line, that's this one. So that's the y equals type of line. So let's just look at the point. What does y equal? Well, y equals negative 3. And it's as simple as that. Which of the following lines are parallel to each other? The easiest way is to color code these. And we're going to solve each for y, put it in slope-intercept form. So I'm going to subtract 2x from both sides. Divide by negative 6. And we end up with y equals negative divided by negative is a positive. 2/6 is 1/3 plus negative 1/2. As far as the blue goes, we're going to subtract 6x from both sides. Then divide by 2. So we have y equals, that's going to be negative 3x plus 3/2. Now for the red. Negative 2x plus 6y equals 3. We're going to add 2x to both sides and divide by 6. So we have y equals, that's 1/3 x plus 1/2. And what you're looking for when they say parallel lines, you really want the slopes to be the same. I see that these two slopes are the same. I also would like the y-intercept to be different. The reason being, you can get a trick question where the slope and the y-intercept is the same. In that case, they're actually the same line. So those would not be parallel simply because it's just one line there. You can't have one parallel line. In this case, the slopes are the same, the y-intercepts are different. So this is definitely the pair. So which of the following lines? The black one, which is this one, and the red one, which is this one. So we'll just say that these are the two parallel lines. All right, number 18. Write an equation of point-slope form of the line passes through that point and has this slope. Then rewrite in slope-intercept form. So we're going to have two answers here. Write it in point-slope form, and rewrite in slope-intercept form. Okay, so y minus y1 equals m onto x minus x1. Remember that we plug in numbers in the y sub 1, m, and x sub 1 slots. We leave the x and y alone. We do not plug anything there. So this is my x, this is my y. I have y minus y1, which is negative 7. M, which is 1/2. Up to x minus x1, which is going to be 4. Now I need to rewrite this in slope-intercept form. So I'm going to write it down here. I can go ahead and keep change. It's going to be y plus 7 equals 1/2 onto x minus 4. Here's the nice thing about using point-slope form. Anytime I try to convert it to slope-intercept form, there's two things I do. First, I distribute. 1/2 of 4 is really like 4 divided by 2, which is 2. And now we're going to subtract. And there we have it. Number 18, y equals 1/2 x minus 9. Number 19, the clearinghouse has resistors that sell for $3.50 a pound. What about some electronics terms here? And circuit boards that sell for $2.25 a pound. Write a linear equation that represents how much of each type of electronic equipment can be bought with $13. Now, remember I told you there were 3 different types of things that we can look for. Well, that does not work with a standard form type of a word problem. And this is exactly that kind of a problem. Now, we do need to define, there's no way we would know if we just say randomly x and y, which one's which. So we're going to go ahead and define. Let R equal number of pounds of resistors. We're also going to let C equal the number of pounds of circuit boards. Okay. Resistors, $3.50 a pound, so $3.50 for the resistor, plus $2.25 a pound for the circuit boards. All total, that is $13. And that's basically it. Now we could take this off. And that gives me my linear model. In this case, the linear model is a standard form equation. Okay, last but not least on the review. Write the standard form of the equation with a line of slope 4 passing through the point -5, 5. Now, there are 2 different strategies we could use here, and I'd actually like to show you both strategies. The first one is to use the close and then go into standard form. The second one is to use point slope. So we're going to start with the close. First close is the slope. The second one is the y-intercept. Well, we know the slope. The slope is 4. We also have this point, -5, 5. This is x. This is y. We're going to plug it into y equals mx plus b to find our other close. So y, which is 5, equals m, which is 4, x, which is -5, plus b, which is unknown. 5 equals -20 plus b. We're going to add 20 to both sides. And b equals +25. Now, these close are good for getting my slope-intercept form. The problem is that this is not in standard form. For me to get this into standard form, I'm going to have to subtract 4x from both sides. Get -4x plus y equals 25. This would be nice, except that I don't have the leading coefficient to be positive. So I'm going to multiply everything by -1. And that's going to basically reverse these 3 signs. -4x times -1 is going to be a +4x. Positive positive 1y times negative 1y is going to give me a negative 1y, or just minus y. And 25 times negative 1 is going to be negative 25. There's my standard form. So again, use your close, get your slope-intercept form, and convert that into standard form. The other way is to start with point-slope form. Remember, y minus y1 equals m onto x minus x1. Well, y minus 5 equals m, which is 4, onto x minus negative 5. Keep, change, change. Remember, 2 easy steps to be able to get my slope-intercept form. Distribute, and add 5. So y equals 4x plus 25. You notice we're to the same point that we were here. Now we just continue. Subtract 4x from both sides. And now I multiply everything by negative 1. Negative 4x times negative 1, positive 4x. 1y times negative 1y is negative 1y, or just minus y. And positive 25 times negative 1 is negative 25. And that'll do it for Crazy Math Productions today. Thank you for listening. I would strongly encourage you to go through, try each problem on the review, pause, and then come back and see if you've gotten it correct by playing the video again. Thank you very much, and have a great day.